The other important part of section 4.2 is what's called the mean value theorem. This is sometimes referred to as the MVT. It's used so frequently in calculus that you can actually refer to it as the MVT, and everyone will know what you're talking about. So this is a theorem. It says if a function f of x is continuous on a closed interval, so closed interval with the brackets, meaning a and b are included, and differentiable over the same interval, but maybe not including the endpoints. So that's why we have the open interval. We use the parentheses. Then I can guarantee you that at least one point C between A and B, this is true. F prime of C is equal to f of B minus f of A over B minus A. So that means that if a function is continuous and differentiable on some interval, that somewhere in that interval, the slope of the secant line is going to be exactly equal to the slope of the tangent line. We're going to get a lot of practice graphing that in class, so you can see what that looks like, but you have to know this definition. These words have to be written in on your paper. So at some point on this function, the average slope, average rate of change, must equal the actual slope, the derivative, evaluated at some value c. So just to clarify some words that you sometimes see on the AP test, this mean value theorem is written as an if-then statement. So you might have learned in geometry, the part that comes right after the if is the hypothesis, and the part that comes after the then is called the conclusion. So the mean value theorem actually has two hypotheses. Make sure you write these in on your paper. If two things. F of x is continuous on the closed interval a to b. That's the first thing. And also, the second thing is, f of x has to be differentiable on the open interval a to b. So, two hypotheses. F of x is continuous over a to b and differentiable over a to b. So those are the two hypotheses. If those happen to be true, then you know something is true. The thing you know is true is, at some point C between A and B, f prime of C equals f of B minus f of A over B minus A. So long story short, the hypotheses are the things that come right after the word if, and the conclusion is what comes after the word then. The conclusion happens to be a little bit longer in this case. So you have a picture on your notes. Make sure you draw this in. You can see on this next slide here. Okay, so what the mean value theorem says, if I have a function that's differentiable and continuous, there we go. So here, this blue function is continuous and differentiable. It's smooth. Then if I draw in the secant line, that's A to B, this line segment A to B, and then I try to figure out, if I use my pencil and pretend it's the tangent line to that curve, that at least one place between A and B, the slope of the tangent line is going to have to equal the slope of that orange line I just drew in. So you can see in your graph where you should make the line AB, the line segment AB, and sketch in the tangent to this blue function f of x. You can see it's already marked for you on your graph. It's at point C, so draw in the tangent line there to make your picture match this graph.